Distortion is the alteration of the original shape of something, such as an object, image, sound or waveform. Distortion is usually unwanted, and so engineers strive to eliminate distortion, or minimize it. In some situations, however, distortion may be desirable. The important signal processing operation of heterodyning is based on nonlinear mixing of signals to cause intermodulation. Distortion is also used as a musical effect, particularly with electric guitars. The addition of noise or other outside signals is not deemed distortion, though the effects of quantization distortion are sometimes deemed noise. A quality measure that explicitly reflects both the noise and the distortion is the signal-to-noise-and-distortion ratio. Electronic signals. In telecommunication and signal processing, a noise-free system can be characterized by a transferred function, such that the output can be written as a function of the input as. When the transferred function comprises only a perfect gain constant A and perfect delay T, the output is undistorted. Distortion occurs when the transferred function f is more complicated than this. If f is a linear function, for instance a filter whose gain and/or delay varies with frequency, the signal suffers linear distortion. Linear distortion does not change the shape of a single sinusoid, but usually changes the shape of a multi-tone signal. This diagram shows the behavior of a signal as it is passed through various distorting functions. The first trace shows the input. It also shows the output from a non-distorting transferred function. A high-pass filter distorts the shape of a square wave by reducing its low-frequency components. This is the cause of the droop seen on the top of the pulses. This pulse distortion can be very significant when a train of pulses must pass through an AC-coupled amplifier. As the sine wave contains only one frequency, its shape is unaltered. A low-pass filter rounds the pulses by removing the high-frequency components. All systems are low-pass to some extent. Note that the phase of the sine wave is different for the low-pass and the high-pass cases, due to the phase distortion of the filters. A slightly nonlinear transferred function, this one gently compresses the peaks of the sine wave, as may be typical of a tube audio amplifier. This generates small amounts of low-order harmonics. A hard clipping transferred function generates high-order harmonics. Parts of the transferred function are flat, which indicates that all information about the input signal has been lost in this region. The transferred function of an ideal amplifier, with perfect gain and delay, is only an approximation. The true behavior of the system is usually different. Nonlinearities in the transferred function of an active device are a common source of nonlinear distortion. In passive components, linear distortion can be caused by inhomogeneities, reflections, and so on in the propagation path. Amplitude distortion. Amplitude distortion is distortion occurring in a system, subsystem, or device when the output amplitude is not a linear function of the input amplitude under specified conditions. Harmonic distortion. Harmonic distortion adds overtones that are whole number multiples of a sound wave's frequencies. Nonlinearities that give rise to amplitude distortion in audio systems are most often measured in terms of the harmonics added to a pure sine wave fed to the system. Harmonic distortion may be expressed in terms of the relative strength of individual components, in decibels, or the root mean square of all harmonic components, total harmonic distortion, as a percentage. The level at which harmonic distortion becomes audible is not straightforward. Different types of distortion are more audible than others even if the THD measurements are identical. Harmonic distortion in RF applications is rarely expressed as THD. Frequency response distortion. Non-flat frequency response is a form of distortion that occurs when different frequencies are amplified by different amounts, caused by filters. For example, the non-uniform frequency response curve of AC-coupled cascade amplifier is an example of frequency distortion. In the audio case, this is mainly caused by room acoustics, poor loudspeakers and microphones, long loudspeaker cables in combination with frequency-dependent loudspeaker impedance, etc. Phase distortion. This form of distortion mostly occurs due to the reactive component, such as capacitive reactance or inductive reactance. Here, all the components of the input signal are not amplified with the same phase shift, hence making some parts of the output signal out of phase with the rest of the output. Group delay distortion can be found only in dispersive media. In a waveguide, propagation velocity varies with frequency. In a filter, group delay tends to peak near the cutoff frequency, resulting in pulse distortion. When analog long-distance trunks were commonplace, for example in 12-channel carrier, group delay distortion had to be corrected in repeaters. Correction of distortion, as the system outputs is given by y, t, equals f, x, t, then if the inverse function phi1 can be found, and used intentionally to distort either the input or the output of the system, then the distortion is corrected. An example of a similar correction is where LP vinyl recordings or FM audio transmissions are deliberately pre-emphasized by a linear filter. The reproducing system applies an inverse filter to make the overall system undistorted. Correction is not possible if the inverse does not exist, for instance if the transferred function has flat spots. This produces an uncorrectable loss of information. Such a situation can occur when an amplifier is overdriving, causing clipping or slew rate distortion when, for a moment, the amplifier characteristics alone and not the input signal determine the output. Cancellation of even-order harmonic distortion. Many symmetrical electronic circuits reduce the magnitude of even harmonics generated by the nonlinearities of the amplifier's components, by combining two signals from opposite halves of the circuit where distortion components that are roughly the same magnitude but out of phase. Examples include push-pull amplifiers and long-tailed pairs. Teletypewriter or modem signaling. In binary signaling such as FSK, distortion is the shifting of the significant instance of the signal pulses from their proper positions relative to the beginning of the start pulse. The magnitude of the distortion is expressed in % of an ideal unit pulse length. This is sometimes called bias distortion. Telegraphic distortion is a similar older problem, distorting the ratio between mark and space intervals. 1. Distortion in art. In the art world, a distortion is any change made by an artist to the size, shape or visual character of a form to express an idea, convey a feeling or enhance visual impact. Often referred to as abstraction, examples of distortion include The Weeping Woman by Picasso and The Adoration of the Shepherds by El Greco. Audio distortion. In this context, distortion refers to any kind of deformation of an output waveform compared to its input, usually clipping, harmonic distortion, or intermodulation distortion caused by nonlinear behavior of electronic components and power supply limitations. Terms for specific types of nonlinear audio distortion include crossover distortion, slew-induced distortion and transient intermodulation. Distortion in music is sometimes intentionally used as an effect, see also overdrive and distortion synthesis. Other forms of audio distortion that may be referred to are non-flat frequency response, compression, modulation, aliasing, quantization noise, wow and flutter from analog media such as vinyl records and magnetic tape. The human ear cannot hear phase distortion, except that it may affect the stereo imaging. In most fields, distortion is characterized as unwanted change to a signal. Optics. In optics, image optical distortion is a divergence from rectilinear projection caused by a change in magnification with increasing distance from the optical axis of an optical system. Map projections. In cartography, a distortion is the misrepresentation of the area or shape of a feature. The Mercator projection, for example, distorts by exaggerating the size of regions at high latitude. See also, aliasing, amplitude distortion, attenuation distortion, bias distortion, crossover distortion, distortion power factor, fading, image warping, intermodulation distortion, lossy compression, total harmonic distortion, tube sound. References: Moskal, Tony. Soundcheck, The Basics of Sound and Sound Systems. Hal Leonard. PA 55, Audio Electronics by John Lindsley Hood. Page 162. This article incorporates a public domain material from the General Services Administration document Federal Standard 1037C.